Hi guys, so we are starting Unit 4 today, which is all about systems of equations and systems of inequalities. Okay. So by the end of this learning target for systems of equations, you should be able to solve systems of equations in two variables graphically. That's what we're going to do today. And we're going to see that our solution is the intersection of our graphs. Okay. We're also going to learn how to solve systems algebraically, substitution and elimination next time. Okay? We're going to learn how to interpret solutions, whether we have one solution, infinitely many solutions, or no solutions, and to use word problems and real-world applications to construct systems. Okay? So we're going to start off here. So if you remember from our previous units, that a solution to an equation can be thought of in two ways, right? So a solution to an equation can be thought of algebraically, where we plug it in and it makes the equation true, okay? Or with a graph where we see that our point, our ordered pair, is on the graph, okay? So we're just going to review a little with exercise 1 here. We're going to verify that 2, 7 is a solution to y equals 2x plus 3. We're going to do it algebraically and graphically. Okay, so let's start with it algebraically. So our equation was y equals 2x plus 3. Right? And to verify that this is a solution, I'm going to plug 2, 7 into my x and y. Okay, so I'm going to substitute y for 7, and I'm going to substitute x for 2. Then, keeping the left side the same, I'm going to check. So 2 times 2 here is 4. 4 plus 3 is 7. And then I check, does it equal each other? Yes, it does. So this verifies algebraically that 2, 7 is a solution. Okay. Then we're going to verify it graphically, and we do that by graphing our linear equation. Okay. So I'm going to start here with my y-intercept, my b. So this is 3, so it's going to be 0, 3 here on the y-axis. Okay. Then, using my slope here, which is 2, I'm going to go up 2 and right 1. 1, 2, right 1. Okay. Then, I'm going to graph my line. I'm going to make sure that it is accurate, that it has a slope of 2 throughout. Okay, and verifying that 2, 7 is a solution, if I look, 2, 7 is right here. It is on my line. So now I just verify that 2, 7 algebraically makes my equation true, which means it's a solution, and graphically it is on the graph, which also makes it a solution. Okay. So now here, the difference is that we have a system of equations. Okay. So understanding systems of equations, a system of linear equations is where we have 2 or more linear equations. Okay? The solution can also be thought of as algebraically and graphically. Okay? Algebraically, it makes all equations true. Okay? So it makes all of the equations in my system true. Okay? And graphically, it is on both graphs at the same time. Okay? So we're going to use this here, y equals x plus 1 and y equals 2x minus 2. We're going to verify that 3, 4 is a solution to the system. Okay? So y equals x plus 1. I'm going to verify algebraically by plugging 3 in for x and 4 in for y. Okay? So I'm plugging 4 in for y. 3 in for x. Okay. Then keeping my left side the same, then I'm going to check 3 plus 1 is 4. Does 4 equal 4? Yes. So it is at least a solution for my first equation in my system. Okay. Then I'm going to do the same thing. I'm going to plug in 3, 4, but this time to my other equation, which is y equals 2x minus 2. Okay. I'm going to plug in 4 in for y. And I'm going to plug in 3 in for x. Keeping my left side the same. Okay. Then 2 times 3 is 6. And then 6 minus 2 is 4. Does 4 equal 4? Yes. So algebraically, I just proved that 3, 4 is a solution to y equals x plus 1 and a solution to y equals 2x minus 2, which means because it is true to both equations, it is a solution to the system. Okay. So now I'm going to graph it. I'm going to graph this one in green. Okay. So starting with my y-intercept at 1. Okay. Then here my slope is also 1, so I'm going to go up 1 over 1. Okay. And then making sure, right, this is why it's important to accurately graph, that you should be going up 1, right 1 throughout your whole graph. And then connect the dots. And then I'm going to graph y equals 2x minus 2 in red. So starting with my y-intercept at -2, I'm going to go up 2, right 1. Okay, and then again, making sure that your slope is the same. Okay, so maybe even plot more of the points there. Okay. And what you can see is that my graph intersects at 3, 4. Oh, it was a little off. It should be right here. It's supposed to intersect there. Right, so let me just make sure. Right, so that's why it's important. Okay, I would have kept. Oh, my points weren't that good. Okay, so when we do systems, it's probably better to do points throughout, so that way it's easier to see, right? Because as you get further and further from your 2 main points, your graph is a little accurate. Okay, so this one is more accurate, right? And I see that it is a solution for both. Okay. So let's flip. Okay. So when we're talking about systems, there are 3 cases. Okay, the first case is that there is one solution, like we saw, where our graph touches in one place. Okay? We know that we have one solution when our slopes are different. Okay? So when our slopes are different, we have one solution. Okay? We end up having no solution, okay, when our graphs are parallel to each other. And what that means is that our slopes are the same. Okay? That's what makes lines parallel, when the slopes are the same and the y-intercepts are different. And then we have infinitely many solutions, or infinite amount of solutions, when our slopes are the same and the y-intercepts are the same. And the reason for that is because the graph for both of the lines will be the exact same line. So these are our 3 cases, right? One solution if it intersects one time, and that's when our slopes are different. We will have no solution because our graphs do not intersect at all when they are parallel. And we know they are parallel when the slopes are the same and the y-intercepts are different. Okay? And we will know that we have infinite or infinitely many solutions when our slopes are the same and our y-intercepts are the same because they're the exact same line. Okay? Let's get started. So here we have 2 equations. The first one is y equals 1/2 x plus 4. The other one here is -x plus y equals 2. Okay. We're going to set up each equation to be graphed. Okay. So this one is nice in slope-intercept form. This one, to make it easier for ourselves, we're going to change it into slope-intercept form by solving for y. So I'm going to add x on both sides. And then what ends up happening is I have y equals x plus 2. Okay. Then we're going to graph it. Okay. So I'm going to graph this one in green. So I'm going to go up 1, 2, 3, 4, because this is my y-intercept at 4. Okay. Then, since my slope is 1/2, I'm going to go up 1, right 2. Okay, and then just because systems, I need to make sure that my line is super accurate, I'm just going to go up 1, right 2 throughout, or the opposite in this case. Okay, and then I'm going to graph my line. Okay, this makes it easier because then I know my graph is accurate. I see every single point on that line. Okay. Then I'm going to graph y equals x plus 2 in red. So starting with 2, my y-intercept. And then here my slope is 1, so I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1. Okay? So in this case, when we're graphing, it's best to do the points throughout your whole graph. Okay? That way it is the most accurate. Okay? So that way we don't see what we had before. Okay? Then all we have to do once we graph it is we look for the intersection where they touch, and that's our answer. Okay? If it is the same line, it'll be infinite solutions, okay, because they'll be the same. Parallel lines will be no solution, and if they intersect at one place, then we just name it. Okay, so here it intersects. This point is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So here my solution is 4, 6. Okay. I'm going to try a couple more here. Okay, so again, I'm going to change it into slope-intercept form. Okay, so I'm going to start with this one here. So 2x plus y equals 4. Since it's not in slope-intercept form, I'm going to change it by solving for y. So I'm going to subtract 2x. So I get y equals negative 2x plus 4. Okay. Then, for the other one, I'm going to do in red. So that's 2y equals 2x plus 2. Okay, again, it's also not in slope-intercept form, so I'm going to divide by 2. And I get y equals 1x plus 1. Okay. Then I just need to graph the line. So starting with my y-intercept for my green line at 4. Then, using my slope of negative 2, I'm going to go down to right 1, 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 down to right 1. Okay. Then I'm going to connect my dots. Okay. I would do points throughout the whole graph. It will make it the most accurate. Just because, as I said before, once you get further and further from those two original points, sometimes it can be a little off. Okay. Then with this one, starting with my y-intercept at 1. Okay. And then here my slope is also a 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, so on and so forth. And then here, since I already see where they meet, I don't have to keep going. And there you go. And so my solution in this case, where they touch, is right here. And this ordered pair is 1, 2. And so my solution for this system is 1, 2. Right? And I can always check my answer by plugging it back in for the x and y and seeing if it's true. Okay? So now I'm going to do my next one here. Okay? Again, I see that it is not in slope-intercept form, so I am going to change it. Okay. So first I'm going to subtract 2x. So I have negative y equals negative 2x minus 1. Okay. It's still not y by itself, so to get rid of the negative, I'm going to divide by negative 1. And this gives me y equals positive 2x plus 1. Okay. Then I'm going to do my next one here, negative 4x plus 2y equals negative 6. Okay, I'm going to solve for y so that it's in slope-intercept form. I'm going to add 4x to both sides. Okay. 2y equals 4x minus 6. Again, you cannot combine these. They are not like terms. Okay. And then to continue solving for y, all I have to do is divide by 2. Okay. So y equals 4 divided by 2 is 2, so 2x. Negative 6 divided by 2 is negative 3. Okay, so then I graph. So starting with my green line, my y-intercept is at 1. Okay. And then my slope is 2, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And then same thing on the other side. Okay. Then all I have to do is connect my dots. I'm good to go. Okay. Then I'm going to do my red line here, y-intercept at -3. Slope is also 2, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay, and then the other side. Then connect my dots. Okay, and what you see is that these are parallel lines. Okay, and I also know that because the slopes are the same and the y-intercepts are different. Right? And since they are parallel lines, that means they're never going to touch, they're never going to intersect, and since they don't intersect, that means I have no solution. Right. Then I'm going to do my last one here. Okay. So y equals -2x plus 3, that is already in slope-intercept form, so I'm good to go. Okay, this one is not, so I'm going to change it. So 6x plus 3y equals 9. I'm going to change it into slope-intercept form by getting y by itself, solving for y. So I'm going to subtract 6x. Okay, then I'm left with 3y equals -6x plus 9. Again, you cannot combine them. They are not like terms. Then I'm going to divide by 3 to get y completely by itself. -6 divided by 3 is -2, so -2x. 9 divided by 3 is 3. Okay. Then I can already see that the line is the exact same. Right? So I already have an idea of what my solution is. Okay, so started with my y-intercept of 3. Then I'm going to go down to right 1, 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 down to right 1. And on the other side. Okay, so graph my line. Then my red line here, so the y-intercept is the same. My slope is the same, so it ends up being the exact same line, which since they're the exact same line then, that means they touch at every point, which means every point on this line is a solution, which means that I have an infinite amount of solutions, or infinitely many solutions. Okay? In this case, it is not all real numbers, right? It's not any point that works. No, it's only the points that are on this line, and there are an infinite amount because they go up and down, right? So the answer is infinitely many solutions. Okay? So that's it for today on solving systems by graphing. Hope you have a great rest of the day. Bye, guys.